Ma Divya, have you initiated YouTube live streaming, ma? Okay.
Okay, recording also you can start.
Yeah, I'll start it, sir. Sir, as soon as the recording is started, I'll start the session, sir.
Okay.
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 Good evening to one and all present here. I welcome you all for this webinar. Now, I request Mr. H.R. Mohan, sir, Chair Events, IEEE CS Madras, to welcome the gathering and also introduce the speaker.
Greetings and good evening to one and all. On behalf of the organizing units, Computer Society of India, Chennai, IEEE Computer Society Madras, ACM Chennai, I extend a warm welcome to our today's eminent speaker, Dr. Jayakumar, members and my colleagues from the organizing units, and the participants joined the Google meeting platform, and those watching the YouTube streaming of the proceeds of this webinar. The IoT, an offshoot from the foundations of RFID, has become the mainstay of many solutions in the current context. Decisions are made by using the large amount of sensor data captured by IoT devices. In the present day, with the developments in big data, AI, ML, have made a great impact in designing AI integrated IoT solutions. Today's presentation on a unified approach for IoT developers will explore how artificial intelligence and machine learning are reshaping the landscape for IoT developers. As the integration of AI with IoT, now it is called AIoT, gains momentum, it is enabling intelligent automation and data-driven decision making, enhancing device functionality and user experience. The discussions will explore how AI and deep learning networks can unify and enhance the IoT development, specifically in enabling AIoT services, optimizing resource utilization, and improving decision-making accuracy, ultimately leading to increased customer satisfaction. For IoT developers, this unified approach is transformative. AIoT integrates advanced deep learning networks directly into IoT frameworks, enabling devices to independently process vast amount of data in real time. This reduces latency and supports smart features like adaptive learning, security improvements, and resource efficient operations, all of which are essential in connected ecosystems. Participants of this presentation will gain insight into emerging tools and methodologies for implementing AIoT solutions that are scalable, efficient, and secure. Ultimately, today's session will help IoT developers leverage AI and deep learning networks to create responsive, intelligent systems that meet the demands of today's connected world. With this brief introduction on the topic of today's presentation, now let me have a great pleasure in formally introducing our speaker, Dr. S. Jayakumar, who is known to me for over a decade through IEEE. We met at the IEEE Student Congress held at IIT Allahabad and continued our professional interactions and deliberations on several technology trends. He has contributed an excellent article in the IEEE India Council newsletter on software-defined radio and its application in several industries, including the defense services. Dr. Jayakumar is a seasoned signal processing engineer with a profound technical background in advanced DSP systems, IoT, and artificial intelligence applications. Currently positioned at Mistral Solutions Private Limited, Bangalore, he brings a decade of experience to the table, coupled with history of significant contributions to high-performance embedded systems. Dr. Jayakumar's career, distinguished by groundbreaking projects and pioneering research, spans a wide array of industries, including aerospace, karaoke technology, audio engineering, communications, and consumer electronics. His contributions in these fields have not only advanced the state of technology, but have also set new standards in innovation, particularly in areas like digital signal processing, all AI-driven solutions, and IoT integration. His work continues to inspire and shape the future of technology in both industry and academia. Dr. Jayakumar's journey in science and technology began with a strong educational foundation, holding a degree in mathematics from Madras University, a BTech in aeronautical engineering from Madras Institute of Technology, and both a master's and doctorate in systems and control engineering from IIT Bombay. He also served in a research fellow as a research fellow at the Katholieke University of Belgium. His professional path has allowed him to work closely with industry leaders, shaping solutions in IoT, AI, and signal processing, where he has developed a particular focus on applying AI to real-world signal processing challenges. Notably, he was involved in designing systems for synthetic music and satellite communication, reflecting his ability to adapt and innovate across diverse technical fields. In addition to his work at Mistral, Dr. Jayakumar has an impressive academic portfolio, including experience as a faculty member, sharing his expertise in system engineering, IoT, and AI at esteemed institutions. His dedication to mentoring young engineers and sharing knowledge through professional networks such as IEEE demonstrate his commitment to empowering the next generation of developers. Recently, he has been appointed as the ambassador for ARM technology. With his brief welcome note and introduction to the topic of the presentation and about the speaker, now let me invite Dr. Jayakumar to enlighten our participants on the unified approach for IoT developers by integrating AI, ML, and IoT. Over to Dr. Jayakumar, please.
Thank you, sir.
first also. Nowadays it's happening. And then you go and look for a developers and designers, right? Designers also quite confused now, which is what, which standard. Like suppose I give an example of IoT, sorry, IEEE 8.11. If you go to some hotel, even some smaller town, even take a smaller town like Tanjavur, where I go very often. So as soon as I go into the room, and then the boy or person who comes there, this is your Wi-Fi password. The word Wi-Fi become a, like amazing popular, even all kind of people among the peoples, like that's what standard means, like any company manufactures interoperability things happening. But IoT does, why it did not happen, what is the challenges in that? That's the place we are today. We are going to into that. If we see here the last sentence, efficient sensor fusion techniques and automated. The what happens is when we measure things, we wanted them to like fuse it and take a decision. Data alone, kilobytes or megabytes or gigabytes of data is not going to give comfort. That's what we call uncertainty in the data give us a lot of discomfort. If I know less about it, if I know more about the uncertainty, then we live in the higher mind of discomfort that was made those industry leaders not to go with IoT. That's what I think after closely seeing this one in the middle of last decade. But now we know it is uncertainty going to live with it. It's not going away. It's not that uncertainty going out of IoT, or it is a measurement techniques or rules or industry semiconductors are introducing new kind of sensors. No, the same old sensor might be like not a little better. It's not a quantum leap of sensing methods and measurements. That's completely same. But what is new thing which we learn is how to live with uncertainty. We know there is a measurement, there is error, we know there is a kind of uncertainty in the whole of IoT devices when bring a massive scale of data. But in that, how we know there are a lot of, olden days in communication engineering, we say SI nothing to noise ratio, but we cannot say this one. So that one here. Of course, individual measurements equals to noise ratio, but the whole of the data giving us a randomness, correct? That gives us an uncomfort decision for managers to, more than a manager, designer to not to touch this, because they at the end the designer doesn't want to be blamed, saying that the equipment not working. When you go for verification validation, if they say that it's not working, the designer will feel very sad, they'll feel hurt. So that's the way the designer wanted to be like given input, what could be the output get. So that kind of clarity, how it will happen, that's what the catch now. So there is a supporting document which is there. If you click this supporting document, you can get this one. That is it is good for all of you to read. I put the complete document here. So that's the way. In fact, sir was telling flipping that lecture series. I love this one because I had people know that when people come into lectures, the students can be very informed then instead of going look for a new thing, right? So this whole document is there, reasonably well written here. Of course, I kept consciously with no equation. One or two places I tried to have some equations, but I want to take this one example here and then we'll go back to that. So I told you about the measurements. If I assume that there are 5 sensors here, so 1, 2, 3, 4, 5 sensors we have. Out of 4, 5 sensors, there might be one sensor might have gone bad. If we include that sensors also, data also into our decision process, will be skewed. Things will come that may not be good. The whole of my learning around here, how to compact this in the presence of red things in the whole of ways, like, this was an uncomfortable thing. The more the red is there in the collected data, we feel that, there is something going very seriously. We don't know how to design a system to handle them, right? So that's the point of time where why I took this historical perspective is to, impart to all of you. This diagrams are very interesting. When I just draw this one in front of Professor S.S. Iyengar, and we both have a book I'll show you later. So she was trying to solve this problem. So of course he solved this problem in 1996 when he was with the Brooks Iyengar algorithm, you can Google it, you'll get. Then sir was telling me, JK, if there is, more than 3 or 4 reds are there, then what is the point in having one screen? How do we handle this? So we went to identify and classify the sensors and then remove the bad ones in the during classification, then take the good ones to fuse. There are 2 steps. Imagine there is algorithm which does both in one, then you are there. Correct. That's the way things will be unified. Things correct. So 2 classes. One is that you have to be classify the red ones and from the green one. Then after that, take the green one for a decision making process. Correct. So we'll come back onto that. But however, this document is there in this thing. You can go with it. Right. But I want to take you for this picture again because here is. I'll come back to the regular mainstream, but I'm just going the silent for you to give the historical perspective of our problem where we are trying to drive. Like a sensor network is the heart of our measurement system. So this has been there last 200, 300 years, correct? At least last 50 years, definitely is there, and most of you would have seen. But, for me, it is, during my student days also, it was quite a strong one, sensor network was there. But apparently, it is not so clean as we think, right? When the sensor we put it, we don't expect the given input, output comes, they're all like, behaved well, like, kind of thing. It has been always a kind of ups and downs, that kind of a probabilistic way. It is called stochastic. There is a word called stochastic. It is not upfront. We do not know the exactly, but there are a kind of guidelines in which the stochastic networks we can model it. Then there is another class called deterministic network. So 2 things, correct? One is a stochastic, another deterministic. Imagine that the sensor networks will belong to deterministic, reasonably good. The driver is driving the bus, then he's seeing the needle 43 or something. So the 43 to 44 will not bother as such. So if it is a 44 goes kilometer, then you take a simulation. But there is some kind of stochastic considered to be deterministic in the human being when the human take a decision. But that is not going to happen for a machine taking decision, correct? When the machine take a decision, any variation is the variations. As a human being, we have an inbuilt tolerant decision-making power. We can, say that, okay, 43.4 or 43.6, same speed, okay, fine, it go. Kind of the embedded machines will have its own problems and understand the thing that's the way we call stochastic networks with the model. And of course, how do we model them? That's a new physics. Old physics problem now become a Nobel Prize this year. Professor Hinton model the stochastic network data sensor network as Boltzmann machines called Boltzmann model networks in our electrical engineering we love to call network, but he's she calling it a machine, but I always say Boltzmann networks or Boltzmann model, but he love to call it some machines. So now what happened that sensor network become a Boltzmann model for us graph here. But in the other side, this is not solved at all. It was there for quite some time. It's going on, and of course when we were young, there is a kind of Kalman filter which will compact this kind of problem things, and then they come up with Kalman filtering and so many things going on. But however, it was not very satisfactory as we are now, right? On the left side, if we see deterministic network, there is a kind of huge things happen all over, right? So we have a called Hopfield network. I'm sure some of you might have heard it this year Nobel Prize. These 2 boxes went for Nobel Prize, okay? For physics, Nobel Prize went into Hopfield network and Boltzmann machine this year. So these 2 are solving same problem, but one person, Hopfield, said how these neurons hold the memory. That's a problem, sir. John Hopfield looked at, but Boltzmann thought that how these networks learn from the data. There are 2 different questions, but map the same physics of the problem. You want to know how the neurons learns. And but Hoffield want to know how this neuron stores the information. One person want to know storing, another person want to learning how the neurons learn. These two, of course, Hoffield has given a quick solution and faded away 1983. But this Professor Hinton, he was stuck on to this problem for quite some time. Now this year he got a Nobel Prize, right? That will come back onto that. But deterministically, there is a lot more thing has happened. Was like unknowingly, this all three unknowingly called Brooks-Engel algorithm. That is actually, if you have a millions of sensors, then if you want to make a decisions, so whether SSI and his boss Brooks, they released an amazing algorithm called during 1996. It's a well referred, more than a 3 lakh references something. I don't know, some 3 million something. It's a huge went from that day onwards. But these were all not well connected. I was thinking of all the three how it's called, correct? In this, so this, I'm just giving guideline for you to how to read this document. Of course, we have Boltzmann machine and a sensor classification, everything. You can read it. This is a fundamental problem today. We want to solve, discuss about it. The section 4 as a problem on IoT devices. I told you it came. Rather, I mentioned you all. This was came, but it's went off the record for 2014 to 2017. Then went down here and there. But 10 years before, I comfortably call it 10 years before, IoT devices came, it went into gray mode, it was in gray mode. But now, that problem is become a little different problem. There is a kind of intelligent IoT device, we call it AIoT, and that comes with a new called edge computing. So we have a new muscle called computing, so we can do a lot of computing. And then there is a deep another capability called artificial intelligence thing, and then we have a third capability called 5G connectivity. These three become a boon, so that's where it's emerging as a solution, service provided, service for the humankind or even machines also. And this brought up the new problem for us is first, like when we look at the world, when here certifying this kind of devices, we have no problems. There is one input, one output. But here, when the AI comes, even though one input goes, there are multiple output comes. We don't know which output comes when, but there is a statistic nature will be there. With this one, I'll go back to our mainline one. So I given a kind of storyline to take you to the subject now. So, of course, it's a good amount of storyline which we went through that. So now we'll go to the main one. There is a kind of a refresh one actually put up. So when some of you can read this one and then fill it. This is a kind of a comical reference, but it's a give you mistake. Of course, this is one I was really worked on it. I hope the people who asked the questions they read and suppose say some questions they Q5 and then there is things. Well, so that I done this one, or rather worked on it. Of course, question 8 was a little rough and tough. It was then so of course it will come back and we'll touch back onto that. So with this, there is a history there, correct? I just told you the history. I did not told you any code or kind of a language or a program or something. This word history we have it in the edge zone last. 20 years of 15 years of time. So with this actually we want to make a success. Then how do we make a success? That's a question now. So in that introductions there is a bit of a again, it's not a history one, but there is a futuristic one. Here we want to propose thing. Now what we discuss about the history one only for you with other things. Now in the introduction we say, okay, we have bad things, we have a tough times. How do we make a good thing? So we're trying to propose kind of things which into the industrial, part of industrial revolution and the designer should love this. Sensor fusion and classification for AIoT edge system. So now comes the question now. History, we saw so many, all these people, they were all independently running around. So now we are bringing two guys, like one of them sensor fusion, another is a sensor classification. Two things. And these two things are the heart of any decision-making process inside IoT. These are the two important things which runs inside IoT or edge systems. And this need to be done. How we are going to do the A part going to do that. Correct. A part going to do this for IoT. That IoT keep getting so much of data from sensors. Of course, it doesn't produce its data. Maybe we don't know it's not generated data. Of course, this comes from security. People say the fake data comes. So how do you handle it? There is that's a different things which I may not be able to touch this one. Of course, I do not work on that. Sometimes people say fake data also coming to that. How so of course that's what Byzantine problems, which talks about how do you really handle the fake data, remove the fake data. Of course, that's the way I was fascinated with Brooks Sanger algorithm. So some sensors comes with what do you call a fake date? Suppose some malfunction comes, some other country people put their own IoT devices and send thousands of them started sending the data. Then our fusion algorithm will be skewed and take a decision in favor of those people what they want. That point of time, essentially, the things is kind of are very very different things will outcome will come. To do that, then that's what with I'm thinking it's more of point region duality. And little before this, a little advanced, point region duality, which I can an academic persons will might this thing they might be able to appreciate. It is a special form of hundred and dual spaces our Fourier transform. And of course, Fourier transform lived last 200, 300 years with us safely. But that is having problem when it come to this kind of problems on the sensor fusion classification, where the signal is not stationary, signal is vanishing. We don't know the minute pattern some places and things. Fourier transform may not be good. That's a way point duality comes. We see this is a kind of tool set which we plan in, which has been very powerful. As a special case, we want to reduce that. This will become Fourier transform as well. Then the other challenges comes. This is actually I entered this problem. This certifying the IoT edges, AIoT. What happens is when the every system we make before we going to sell into the customer in the market, enterprise or consumer, we have to go through the one stage called certification, or the ISO IECs, or in defense we have Semilac, DGCA, or ISRO might have their own certifications. We don't know. So, but there is something called certifications. This has to be there. Without that, it cannot go to market hit. But what is the issue presently now is the certification methods and apparatus for handled very nicely this IoT things. There is a one input, one output. That's fine. People can write a verification and validation. There is a difference between what is a verification and what is a validation. You might have seen system engineering courses. We always debate on that with the students. Some students will say both are same, only there is thing. But anyway, let us come to when the IoT edge devices, when its IA is missing, it's a well-defined system. There is a for a given input, there is a given output. So if you I know some of you would have world enough, thing. The world in this ITU speech codec like G.7x or G.72x and codecs. What they will do, it was MP3, when MP3, MFO. They will give test vectors as an input. So we pass through that one, and that should get a output. And there's another vector will come, and the decoder which writes a speech codec that should match with the bitstream what is come. If it's not there, that will not go through the telecom industry. They will, reject it like it's CPT or even before G dot. So the qualification is very strict, pass or not pass. That's it. It's not I pass 90% or something in the speech codec exam. Of course, audio codec is also same. But very interesting thing was those days no one talks about the encoded part. Encoded part silent. Decoder only will qualify encoder, there are some kind of guidelines will be there. So decoder will be strict test, very, very strict test will be there. So what to do? So that's the way. But what happened? That cannot possible when we bring a new friend, artificial intelligence. That will need not result in the same output. It's a stochastic nature based on that kind of energy level. And the variance will be associated with every time when we measure. Actually, so For example, now if you are in a GPS location, you take in a car, it has a 50 meters, variance there. So a lateral understood the 50-meter. Next time if you take, it will be totally different, but within the 50-meter variance, correct? So that A comes in, and then certifying authorities we did not know how to do. I was thinking that's a problem for us, for different thing. But actually, I made actually computer system president. Yeah, like. 2 months back in Delhi. So I kept in touch with him. Then, sir, as they were conducting one invited workshop in Tokyo, just like you can see, like very recently, like November 1st. Then a link was came, but I was also part of it when I saw the same problem. They trying to find out a testing technology. And they qualify as advanced testing technology. And so here and the link is there, you can take it. They'll go through the same thing, topic of interest, AI testing technology. See here. Testing AI technologies. There are two things. AI, how it helps to test the technology. That's the one thing. Like AI becoming like a human expert. Like, it has, okay, fine, this is the car is sellable, send it to market. The other one is testing AI technology. The AI itself, that is good. It's giving good, what do you call it? Inference or not. That itself, that is second one. Systematic evaluation technologies. So these three things become a theme of interest for all the leading researchers across the globe. This is what happened very recently. You can see the Tokyo also. It's not a world conference or something. It is happening now. I was very fascinated with that. Everyone is touching the same problems, but of course, it's coming up differently, but the problem is same. So the introduction, which we saw that when there are a kind of a way we can go out, we are going out. That's why we are committing. So there are the questions questions they asked in advance. They said, how do you call? There are certain questions, and one of the questions is a unified Excel question came up, like this just a point should be a step-by-step process and so on and so forth. So what happens is when we try to find a new route, the route may not be good, may not be very good, or might be bad as well, but might be good also. But as a researchers, we found that road is good only. No one going to say that their way is bad, right? So when we do R&D and research, we say that it's good, and of course, when it goes for a scrutiny, it goes for other discussions, and things will always changes about it. But with this context, we approach this problem of how do you live with uncertainty and still designer happy to design the system. Imagine we are on the keyboard, we type an email. So suppose I type a keyboard and some place a J is there, I press a J. It should come in J only, that correct? Instead of P, it comes, will be very unhappy, correct? Imagine that kind of randomness is no designer want to design a keyboard. They say, no, you are spoiling my name. I don't want to be part of your design group, they say. So that is a bit bigger level of thing. Suppose there are so much of dust in the one area, or like suppose Marina Beach, then immediately so there is a Marina Beach, just something happening. Like it's a global kind of things, are micro and macro kind of things. But the sensor problem now today is a macro things. Micro measurement decisions are macro, thousands and millions and hundreds, or jointly together participate and take a decision actually. That's like biological system also. They participate. To a decision. Millions of them participate in one decision. Correct. So that way there is a classification. Fusion is a key thing. That's how each sensor is. Suppose a multi-model sensors, every sensor puts out their own model. Then there is, there is no standard. There is no unified thing. That's extremely challenge. To figure out what, then you have to do hundreds of if then else, if this, if that, that is not going to end anywhere. Of olden days, when I was young, there is one system called expert system, right? So it will be like expert system, which is gone into gray areas. But here we need a kind of a thing which handles fusion, and then sensor classification, which I talked about. There are certain things we need to remove it even before we take a decision process actually. And there are three methods which I talked about it. A in IoT 4 chapter, certifying which talked about, MBSE, here, this is of course one of the popular standards in the aerospace industry. Of course, it's coming to IBM also. They have a very strongly used model-based systems engineering. They call a rational rows and doors. It's a product. Even before the coding done and the whole thing was verification, validation would have done the product in the simulation itself. And now the new name called digital twin. And the world names, of course, we simulate it, emulate it, and so hardware in loop, system in loop, and human loop. So many variations will be there, right? So then we have an advanced, to an example, I'm not going to touch this. When you have time, you can look at it. When I given a three interesting appendices, actually, this full appendix, here is appendix. So there is a point-range and duality in signal processing and deep learning network, MPSC. These are all come a little different way. So I'm not going to look them because history perspective put them. So they are there, great. One minute, there calling some video calls come. Okay, so now we will can rush through. Now we've done given a quite amount of historical perspective as well as a kind of a problem sensitiveness and importance. I'll just go to the this one, sensor fusions. So there are a couple of data that our friend Graph is coming here in the fusions. The question comes: find a model of binary. What is a model? For some sensor keeps sending data for 5 seconds or 5 minutes. Then they want to find a model of a given binary data. Suppose next question: what is the need to model the binary data? Question can ask: why should I model that sensor data? Third thing is what I can do with the model. Third thing is, of course, assume that we model what I can do with that. Then what we can done with the model that emerges from the binary data? Is there any way I can use it? Here, the fifth question is interesting question. How is the probability assigned to each binary vector? This is what measurability comes into picture now. Until then, the measurability is not into that. The fifth question dope slowly, the probability of, being this event happened or not happened. It's, there is a kind of, number is getting assigned here. What is the connection between weights and words? So I'll leave the sixth one, not very interesting now, but fifth is enough for us to understand today's lectures, right? Of course, it's also very important. But there are a story already told, bicentennial general problem. It is a distributed computing researchers would definitely, they would have encountered day by day, day in and day out, these problems. Of course, it was very popular there. But now that problems, essentially what happened is, given the end sensors, how do we know, some bad sensors, in that, and we need to remove them or classify them. That's where more of a classification it comes. But this one, Boltzmann machine and sensor network, what happens is here, there, it comes kind of a stochastic gradient method, gradients, stochastic model. In that model, there is a kind of parameterized model. Actually, the parameters is energy parameters. Very important. The parameters are not straight space parameter. This is not a polynomial. Some a comma b comma c a1 a2 square like that. It's very sad that Boltzmann, when he proposed this, formula, like T is the parameters, and of course people did not accept it. Of course, those days there is a discrepancy between model-based people and experiment-based people. This is around that place now is called Munich. I think here Boltzmann proposed this model saying that the probability of finding the atoms for the given energy this much if the temperature is so much. But experiment people did not agree. Of course, he never seen the success in his life, but he ended like kind of thing. So, but that has become a very, very interesting. That's what got the Nobel Prize for Hinton, because he loved this formula, then formula loved him back, I think. So, Colmero complexity. Of course, here only we are bringing another mainline thing called, most of us we know called information theory, which is called Shannon information. Shannon basically essentially tell that given the informations and then find the disorder in it, measure it, and things like that. He did not ask the question about the source which generated the data. But Kolmeg Rao, asked this question: what is that one which created this data? Which is the source which has created the data? So that's what he asked. That problem is very interesting. Now it's modeling the source. That's what we talk about. Now we look at the autonomous system which carry all these things. In the, for example, car, this problem well stated here. You can see the problem is a typical IoT edge environment. Multiple sensors may collect data for a single parameter on a given area. Some sensors, however, may provide a faulty reading due to hardware issues, environmental interference, or communication given up. It is giving much more easier than a fusion one. Classification problem reasonably less here. So here also, which we see, this is what happening, like Brooks Triangle, PA means Brooks Triangle. It's a beautiful word for signal classification, which I see that one. So it's like a pre-runner even before use the sensor data in the model-based ones, actually, right? So now, since we are rushing to time, I'll go into the AIoT, which is a core focus for us. So I told you that this one IoT alone, there is a problem. So we are in a gray. But when these three are joined, then we are succeeded in that. We are trying to succeed, not succeeded. We are trying to succeed now for intelligent IoT device by using edge computing, AI, and 5G, three things together. Even the but here is example is like autonomous system. It's not a theoretical or a PowerPoint or something. Now all of us know that Tesla car is running without driver, correct? That's the proof like kind of thing. Of course, these are all things happening. We do not know how Tesla essentially managing this. Of course, they may not have patented it out, or they might be trade secret, but there is a reality, there is a working system for intelligent researchers like us to figure out how how this handled there. Like at least we know it is doable. Like only we do not know how and when. Like the things, of course, when is interesting questions. So we 4, 5. Okay. And the certificate, I already given you kind of issues around that, which is the entropy zero means they're happy, but it has the subsistence, of course, LRU, you are going to put in aeroplane, that LRU has to go for a similar certification, then it's a well-documented report will be there, that input output flow has to match exactly, otherwise they'll send back, right? So, but there is that LRU going to have unobservable units, of course they are, and as an entropy in it, then the issues how we are going to that. So that's a way, like we trying to get this one. The conclusion is certifying cognitive IoT requires a paradigm shift in how approach complexity and uncertainty by leveraging principles of complexity, entropy, and unobservable units. What we say, we can manage it, right? So here, let's go to MBSE one. So LFS, we know this is what which is really looking for it. So unification factors. It has a layered architectures. Maybe I'll put out one architectures for you before, which is very predominantly in the industry. It's coming around this architecture after Android and other things like that. A application layer on the top. After that, we have two layers. We have some like a PyTorch, TensorFlow, and what you call DL train. Of course, this DL train is our own. Like we have complete control in source code, and PyTorch and TensorFlow we don't have any control in source code, so open source, right? So the Python. And another languages also, some of the languages are gone, some like a Python is emerged one, once if there is a language layer, there are many. And library, this is a very, very important because without library, we cannot make a product. We cannot keep doing everything from the beginning. MATLAB's become popular because they supported something, right? So the library also, there is vendors has to come forward and then sell and license it and so on and so forth. Presently CUDA libraries were available with them. But when you certify in the product, do we certify this library also, issues, correct? So, but we don't have source code of them because they're built on the, open source codes. Open source we don't have control on it, what dependencies. So it has become a real mess for us to in the top floor actually. Open source culture there. And predominantly open source. See, none of them are proprietary. PyTorch is open source, believe me. TensorFlow is completely open. We don't know how they will grow morning to evening. So they'll bring us so much of uncertainty in their tools itself. Forget about data. In their tools itself have too many uncertainty comes into that. So we have kind of library and OS also, which is look at everyone going to go with their own. We don't know what OS Tesla runs it also, correct? It's called third party OS. I'll put it a light green there. And Jetson has their own and Android as a popular one. Without that, we cannot go and do everything if then else formula, correct? OS hardware, this is a beautiful thing. All semiconductor industries, like, server market, the embedded market only predominantly control the world in the kind of embedded system, like a Texas Instrument, devices, there are a few more companies, Renesas Electronics, and olden days it's Quick and Motorola also was there. Now they are not. And now it's called NXP and Philips. NXP is there. And this kind of sister companies were giving that their own product. But what is key thing here is ARM and DSP is there. DSP you can see already it's faded away in the gray. It is not contributing to, not able to fight with the modern, skills required and kind of things, but easy to do work with ARM and then do things. So it's very tough to handle the right side once going on. As a designer, they want to remove as much as possible, then engage ARM more and more. But this alone is not good for us. We need acceleration also, right? Without acceleration, no decision. That's what I did computing. The cost of computing is very low here actually. It's like, imagine $1 you have one GPU core. One CUDA core, like, one GPU can have thousands of CUDA core, like, it will get for $300, like 3 cores per dollar, right? So that's a GPU. Then DP, like a dot product engines, a lot of things are happening around. Then FPGA, so world one, it is still around. There's a defense people now, this one sometimes defense systems, but that has been on get GPU getting on threat head on with the FPGA sky. So what is this last thing is the new things are coming called CUDA core, tensor cores. These are all the things there. How do we, handle them in the certification process? How do we model them? How do we really unify them? And, in this here itself, we see so many variables in one product. The top layers, are full of open source, bottom the different kind of silicon. Not a one silicon, one board will have too many variety of silicon. And not top with memory is still worse than this actually. So with these conditions, what we can do, so there is another architecture which I want to show you here is like layered architectures, which is we just discussed about it. So what is happening? The data become this. When you have a little time, you can take this one. And how do we data become model? We have this, correct? I'm looking for one more click that is essentially going to. Okay, so the unification, so the question comes back on unification. What is the model, which is where it is going for us actually? So I'll come back to the thing. What is the unifications like? IoT data. Are we unifying the data level, like output of every sensors? Can we add it on data up to sensors? One is a camera, another is of course say. A voice, can we add them arithmetically? No, right? So we need to have something new model mathematics out there. That's the way the edge computing comes into picture. The AI and edge computing together bring out the model, unifying the sensors, and then make a meaning out of it. You may now Tesla, the car itself, you see examples. If you see car, Tesla cars, we have like radars, called MMV radar, then have cameras, and then we have Even lidars might be having it. I do not know that. But some of the sensors also there in that. All of them put together, they take a real time decision to navigation purposes actually, and that's the way they were coming into that one. Finally, they say car has to move forward or not, whether at what speed they had to move forward. The two decisions they had to take at any given point of times, continuously it's happening. So to do that, we need to fuel this to the red and green. Red and green. Sometimes, the blue is not there also working, but limited connectivity also working for us because on board we are doing high-end computing. So this is a way now, and that it's not that correct all are 100% perfect, but still Tesla car could be able to drop a person, the paid customer from point A to point B without any accident thing. That means we are overcoming the uncertainty, but still fulfilling the functional requirement given by the services called the car has to drop the people from one point to another point without accident safely. That way, if you model them in terms of a requirement layer or like architecture layer or in the design layer, or in the coding layer. So what is a unified model? I told the architecture layer, if we do, then we can do a kind of a good simulations, get on to the thing. But the fundamentally, which we do critical technology tricks which we play here, sensor fusion and classifications. But that is given you kind of a mathematical background also. I think with this, I can look for your questions if things that from your end. Of course, all there in this, you can take it actually. This is you have it here. This reference also, which is there, it's readable. I already show you it. Of course, maybe I should take one more minute and then go for and then show certain things for you, like one thing which is done. Of course, sir is mentioned in that. This page is available for you all. They can take it. We have a kind of references. The publication, what I talked now, these are the publication, which is the three class of publication come in there. There are three papers worked with Sanjeev, Dr. Sanjeev Salpal, Netherlands. Thanks to him, I should have thanked him first itself. And with him, there are three articles we wrote, very interesting article. One of them AIML and IoT, a unified view of the concept and tool chain and ARM processor technology. So that's the kind of unification we are talking about it. And then talk about AI and AIDL model is not an algorithm. We have proved that the deep learning model is not an algorithm, and that is a model, it's a stochastic nature. Algorithm means it's a deterministic nature in that. So that's the way, which is the second one. The third one, much more interesting, from IoT to AIoT. So journey, what I told you is that is fully documented and then well written into this, you can get it. So the other class of paper, which is I talked, which here it is a 5G in IoT. Sorry, IoT in 5G. It is written 4 years back. And it is published, TechX in UAE, Middle East, where we thought that, market is emerging there. So if you, that's a place which is there. But this first article is very, very interesting, which is, you can say it as a kind of, this is a classic one I drawn. So, the editor also approved this diagram. So it is not, what you call, clearly written or something. So the left side is a 4G, right side is 5G. Given a lot of IoT interfaces here. So this article will answer some of the questions that people asked in the upfront think in the sessions. So there is a second one in this is a very beautiful thing, which is which talked about the kind of various model and things which is IEEE 1421. 45-1, as our friend Marti from Hyderabad, they were they were very powerful in this. We collaborated with him, thanks to him also, and this well documented part. So there are, then we talked about the this is what I call like modern. It'll have a kind of GPUs and GPUs, and then you have a network computers like So that's a place is going to be on that, and this one so few of the questions came and ran around this publications actually. So there's a beautiful application actually how the tomato growers can use AI and that AI and IoT to monitor this. Imagine we have a Kolar to Bangalore, like a huge landscape of 100 kilometers full of tomato grows, right? So we don't get this color of tomato in India. That's what McDonald's and other people will not buy a tomato from us because there is some yellow some places here and there. So they will, and so they're importing tomatoes, and that's what they told me when I started this project. What is happening is now the measurement people who are not well versed with all of like us, and then they can take a mobile phone and keep walking around on the thing, and then just take a pictures. And of course, that time I used a Watson, IBM Watson actually. So now that is not that. Also to measure, and this is become a very popular solutions. In Europe, there are the companies which is especially on in the massive scale of measurement and the thing they were taking up. It's called Water Watch Corporation or something, which they were kind of going much ahead, but we couldn't get win better. So this is a beautiful thing. I used to do this whole thing with IBM Watson as a cloud thing. It was amazing infrastructure which IBM rolled out, which I used it and then get things done through that instead of having our own computers in our home and kind of thing. So this application also which we put into that. So the important paper will come. Paper this is a very very interesting paper which we wrote. Sensor fusion and quantum-reality. It is Professor S.S. Iyengar and me and Dr. Chowdhury from National Forensic Science University. And there will be three had authored that. It is there sure. This paper essentially giving foundation for the whatever sensor fusion, sensor classification, which talked about that, and culminate of source modeling. These three things which we done, and then this how the source models go. That source model is a unified paras actually. So this paper, which is there under that, went on public. So most happy thing is in the life is this part. Of course, the book which we wrote. Yes, of course, we did not say deep learning machines. We want to stick on the deep learning networks. A lot of discussion on that. So this is the me is past Jayakumar, and second Professor Iyengar is one of renowned and professors. I'm so happy to work with him in person and discussions and having a coffee and then doing lot more discussion, get things done. It's amazing brain out there like Professor Asad Madani. He's amazing professors UCLA University of Professor S. Iyengar from Florida International University. He was a director of popular lab out there. But Professor Asad M. Madani, Professor UCLA, he was a top teaching award from IEEE last year. You got in it. This week 3 are got into that. Of course, there about them you can see bottom of written there. Everything you can see it. This is in the stand. Of course, it's a little expensive. Things which might come down now. It is 109 to 106 is coming up. Like that's what it is there. Like and they say 5 years laptops. So this is what I have it now. I think these are all the references on which I built up our innovation research, whatever we talked about it too. And there is a tool set one which we can people I know what is happening. Something called now DSP's forgotten places, correct? Many people, but it's coming very interesting. In this I can experiment and things you can go through that. IC design also we try and have a open source things like an ARM, which is there. Like maybe I just give 1 minute take into that. This IoT edges all smart sense thing will go and have like and then they call a stringflation. That means like biscuit size packet size same, but number may be reduced. It looks but price is same like so after so semiconductor industry is also going like that. For IoTs we have to do this one. Otherwise we no way we can go and meet the cost as well as quality of supply in the market to do that. There is something called microwatt. This IBM's introduced this for open source from there. Thanks to them for being so kind. And so like ARM code, it's not like ARM code. It's this code has a PowerPC instruction set architecture is there in this code. I saw it's there in that. But PowerPC is a huge, thing. But this is a very smaller instruction set, which is actually now IBM and even VIT also putting. Morning also we had a call onto that. So they were all putting effort to prove them in the FPGA first. So those details are given. Worked out GHDL part of it also into that. Then design verification where FPGA flow is given. Now moving into ASIC flow for that. It's going on to make the bottom of our layers architectures. What is happening here is now we want to work more in the code generation rather than code writing. So I feel that's a way things going to happen now, because more and more certification, more and more large scale things. Now code generation taken is a major interesting thing. Apart from this, all the things which I thought I should share with you all today. With this, I can hand over it, sir. Sir can take it like then.
Thank you, sir. Thank you for the very elaborated and wonderful session. So you just had a full walkthrough of your content, what you have shared and what is there in your site. Thank you so much, sir. There are a few questions that has been asked during the registration, and now also in the chat box question is posted. So I'll just ask one by one, sir. Shall I, sir?
Yes, ma'am. But
Yes,
the
sir.
question which they asked on that our advanced question, luckily at the time was there, I worked out for them. It is there like kind of thing. So,
Oh,
I'll
okay.
show that page I'll show you now. 1 minute, ma'am. So this question and Q&A, here it is there. So this here, I think 17 questions there came up. Suppose take a question 11. So the author is Pratika, and what she asked is, what is the future of quantum computing, communication systems, and so something like that. So like every questions, everyone asks a questions. Maybe the first question first, and we will take
Yes, sir.
one. So that then the answer also given. We'll click a link on it. Machine learning frameworks and deployment. Very detailed answers given to them. I hope they will be very happy. In case if you found it something more to add on something, direct most welcome, ma'am.
Yes, sir. Sir, there is one question asked by Sarat, sir. The message he has sent is in the chat boxes. Thanks for enlightening us on IoT covering sensor fusion and classification. While IoT systems are by nature deterministic and AI being probabilistic, how effective is this unification in practical industry control system?
Oh, very interesting. This is what I given one working example. Thanks, ma'am. Thanks for the person who asked this question. This is what where the confidence building for us, handling with uncertainty, and then uncertainty become uncomfortable. That's what we always thought, correct? How we can going to become, comfortable. So that's where unification way we are going to take like a requirement layer, functional requirement, technical requirement. Then there is a kind of architecture, then there is a design, then there is a model, then design, then there is a coding. Coding comes after design, right? Design time only. Coding for hardware or software both. Then comes for a manufacturing, testing, validation. The unification where it's going to happen is the question now. If the more we do in the data near to sensor, the more the difficulty for us. So collective sensor going to give us a more information. We can handle the uncertainty. So that's a more number of reading better for us. That's one way we can handle. So in fact, this paper essentially which is talks about it is for you is how the uncertainty become helpful for us. So this is a very interesting thing is which is talk about is uncertainty is not a very bad thing for AI. And that's what machines allows for uncertainty only to find out the pattern in that theory of learning. there is a nice link is there in this called theory of learning for uncertainty. It's no more uncomfortable. Nicely written one. Please do read. But essentially, it means that the network Boltzmann machines happily capture this uncertainty in the model. That's what it means. Like, yes, ma'am.
Thank you, sir. All the questions you have just answered in your portal. One general question, sir. Mr. Ram Babu, he's from a physics background, but he's interested in IoT. He's just asking, how can I get further knowledge to enhance my learning?
Oh, actually, that's a very good question. Of course, what do you now? You see, of course, I do work with the younger generations who's not CS student, like even physics student and other math students mostly now. And other what is being embedded system. We foresee the embedded engineers onboard IoT very easily and quickly, because they know hardware, how to design a board, and they know how to bring up the board, then how to write the drivers, how to make those things, IoT side embedded people can come out well. But what happens is AI part, that's a lot of sensors, whatever IoT reads, that has to be meaningful when sensors and the physics are coming very strong and mass coming stress. Until then, there is no meaning in it. So with this, they can really model the sensors very well. And the Boltzmann machine, what we given today's Professor Hinton and team, it might be like an eye opener. Might be too many things might happen. So I think younger generation get together, if they keep the focus on the customer requirement, and they can invent and then bring out the value onto the product. Actually, that's where she can add a value on it. Or Rambabu can add a value on it.
Thank you, sir. So all the other answer in your presentation itself, and also some of the questions you have just also answered through your Q&A just you have created. And thank you first for taking so much effort on answering each and every question in detail in your site. Thank you so much, sir, and thank you for the wonderful session. Now, is there any more queries from the participants?
Ma'am, I have one question, ma'am.
Yes.
Yes, sir.
Yes.
Yeah. Sir, actually, suppose if I am deploying 100 sensors in a different places, now sensors will give the data to the server and server will analyze. What is the role of AI in analyzing the data or measuring the performance of the sensors?
Okay. So you have the hundreds of sensors, then measuring the same parameter or different parameters?
Measuring the same parameter in a different location.
Oh, very good. This is the classical problem where the classical problem where Proust-Iyengar algorithm solves that. It's a Byzantine problem also. This is an exact problem. What happens is we measure 100 of them, 100 sensors coming data streaming into that, forget about server or something. Imagine that we have got 100 data and then 100 of them, 4 or 5 are misbehaved, they're fault, they're gone, they would have given a wrong reading. If we take a meaning, while taking a decision, if all the faulty sensor also into our decision process, we'll have a faulty read, decision will skew, like variance will skew, and things will go wrongly and so on and so forth. So the first thing is I will talk about the section 4, section 3 is a classification, right? Remove the unwanted, erroneous faulty data, but sometimes may not be possible. With the classical sense possible, that's what the as a signal classification one, like a sensor class, something wrong, we need to move them. See, like a CNN network, we can use it for classifying the sensor. Then we can take another group, which is they're all statistically agree one model parameters where they are. Then you can use them in the views. If we don't have a model of that one, what is a good data from the requirement, the customer given the requirement, in that we have a statistical model for the requirement. There is this is what performance should be. Then if we are within that boundaries, then we are done with it, correct? Example, let's given you the car itself. The car has to take a person from MG Road to say Elanco. Then the car is taken without drivers from MG Road to Elanco, done the purpose car, right? And the requirement is car as autopilot has to drive the car from one point to another point without accident. It's a functional requirement. Might be there I would have done left to 5 feet here, left to 3 feet forward, but functionally it met the requirement, so we call it agree that. That's the way sensor fusion is essentially thing. You had read that, you can go through that, Dr. Sanjeev Satpal in my paper, which I was talking about, blog, in that we address this problem actually, like multiple readings, how do we read? Historically, what happened, if you see, 10, 15 years back, I see a lot of theses, in particular, anonymity, sensor fusion itself. I'm sure so many theses would have come up. But, the problem approach was very differently is done in this Professor Hinton and Professor S.S. Iyengar and the Professor Huffield also. They took the problem to physics fold and then tried to convert them into one instead of put if then logic and just simulator or one write down simulator and see where it is. That's what I think. It's a classical problem, but it has a solution. You can go through the sensor classification Byzantine or Brooks-String algorithm or CNNs, or you can make a fusion also. Uncertainty is taken care and bring that better model out of it actually. Train the neural network with uncertainty also inbuilt on it actually.
Now, another question, sir. Thank you, sir. Actually, IoT is there, Internet of Things.
Yeah.
That will give some functionality. If you add AIoT, then are you enhancing the existing system, or it will rely on sensors, deployed in sensors, or it is a system will take care about the IoT data?
No, my dear, the first question itself you had this one because IoT is required. It's not that not it is a fundamental. But the problem with the data, the IoT produces a data, how a machine going to decisions? Like if intelligent people like you or someone there, then take a decision, oh, this sensor is gone, remove it, throw it. How the machine is going to do? That's why we need algorithm, we need a models, we need all those things, correct? The AI comes to handle the data. It models the data. What is the AI essentially? Brooks and not Brooks. What is it? Boltzmann distribution. It converts the data. Like I shouldn't say convert. It transition the data from the networks. That's mathematically say. In the loose language, data become a model. So the hundreds of the data become a model. Then model you can do too many things. You can find out you can use it for prediction, or you can use it for smoothing, or you can use it for some other query. It's a model is always gold, right? So that's the way the data you forget and then become model. Some of the people asked in the one question came from data security. Actually, data security doesn't have a meaning here for us. What happens is data become model for us, correct? Model security is important more than data because we throw the data after it become a model, right? We don't carry the data set. Also, it's a truth in the sets. We don't carry the ones. Imagine after 10th standard, the one student goes to school. Take 8th standard, 1 to 8. The village teachers, 8 of them, 10 of them, made one children to learn certain things, and the students are able to capable enough to go and learn 11th and 12th. So student only goes. The teachers are not going there, right? They trained. So the student goes with the trained knowledge in that. So his or neural network, capable enough to go and handle the situation it's going to arise in 11th and 12th, correct? That's the way we train the students. Will go to send them to higher education. Then the goes on. Neural network also same thing. We train the network and send the network to IoT as the devices, subsystem, and ask the network to take a decision actually. Network means trained network.
Thank you, sir. Thank you very much, sir.
Thank you.
One question.
Yeah.
Sir, actually, you say that this IoT, which is going to be implemented in one particular place, you consider that a scenario, a particular agriculture field for some 1 acre or something like that, no? When you establish this IoT and this particular field is getting rid of a data set of a small quantity, and how this AI can give suggestion based on this small quantity? Is it necessary that there must be a huge quantity of data set to provide suggestion for the farmer, or the availability nature of the land form where the IoT has been fixed will help the farmer to give guidance for better improvement?
No, here, my dear, this question is very interesting one because I want to give you historical note. Yes, sir.
Yeah, can you stop presenting and then come on the video?
Sir, oh, like that. Okay, okay. Okay, 1 minute, sir. 1 minute. I'll do that. 1 minute, sir. When I do stop presenting, stop sharing. Okay. So I'll put the video also. The video also. See, the question, interesting question is, I'll take back to the why Nobel Prize delayed by 26 or almost 24 years, correct? For Hinton. 1986, sir, start almost practically he completed 1986. Professor Hinton, Geoffrey Hinton, Toronto University, or how to train the neural network. He almost done, like, backpropagation algorithm. There is a neural network. There is, of course, CNN was not there. NN. So he completed the training the neural network and with the data set. But where he, where he not able to make an impact on the world, or he frustrated life for more than 20 years until Elias Sutkis come to his life as a graduate student. Elias said, sir, it's not going to work until you pump a huge number of data and a huge number of neurons. That's the number become. Of course, even today there is a question whether mathematically how Elias statement is proven, but Russian origin mathematically very strong. Him and he come out idea saying that propose his professor, his boss. So sir, we should not handle a small huge data. Then then we give thousands of data, like 40,000 files or 100K file. This is what Elias thing. Until then, people like computer vision and all hodgepodge way. You put this, like kind of things went on for time. Here, what happened at the end? Of course, the professor was inclined to innovations always, right? He was listening to Ilya, I think, and Ilya and Alex, another student came for them. These three cracked the first innovation into the whole step up to 24 years called AlexNet. So they could able to classify data much better than other people at that time. 17% less error than other. The closest competition is having plus 17% error. Then the world looked at what is this like. When you said smaller data, we talked about it, and then you want to generalize into that. That's not going to be there. The data set has to be really good enough that the question is coming, what is a good enough? There is like a Shannon theorem says that if I sample this one, so much of samples required to reproduce a periodic signal and so on and so forth for Fourier transforms. But we don't know that kind of sampling necessary and sufficient conditions. What is the data? But Elias is a huge data. Okay, Elias is one. That's the way they found the success. They tasted the success. But there are his professor also given us some amount of hint on your question called MCMC, Marco Chain Monte Carlo methods for sampling. It's not what you are small or big. What data you are picking up. That's what is important. Some students, study only 5 minutes, score 90. Some students might study whole 24 hours, they may not score 60 also, correct? What data they took is important. That's what Professor Hinton says at MCMC, Monte Carlo and Marco Chain and Monte Carlo sampling methods is there. Of course, there is one more sampling method actually. That way, there is no standard theorem or a mathematical proof to say that necessary and sufficient condition for the data set size.
Jayakumar, video on, please.
Thank you, sir. Thank you.
Welcome.
You have switched off your video, Jayakumar.
No, sir. Video on, sir.
No, sir, video is on.
Video on, is it?
Now it is not showing, sir.
Now only I just since sir complained, I tried to toggle it, but once again I'll go back to the other.
Is it visible?
It is visible, sir.
Yeah, visible, sir. Visible, sir.
Okay.
So interesting.
No, sir, I think by mistake they.
Okay.
So if there is no further queries, now I request Mr. Dr. Murali Bhaskaran, Treasurer, Computer Society of India, Chennai chapter, to propose the formal vote of thanks.
Yeah. Thank you, ma'am. Sir, Jayakumar, sir, it's a very wonderful session. It's a thoughtful information you have given. Normally, application is very important. That is sensors network and working with sensors and new technologies incorporating in that. And definitely this will be useful for our, it's a really eye opener. Many of us we are doing sensor network, but based on neural networks and all. Now the AI is playing the vital role. So definitely this, it's a good session, sir. Thank you very much for your elaborate information for us. It's a wonderful session. And I thank HR Mohan, sir, for continuously supporting us to bring a lot of people for this society. And I thank the Komathy ma'am, in spite of his illness, he has participated. Thank you, ma'am. And Agila, ma'am, and all the members who spend your time to listen Jayakumar sir's lecture. It's very wonderful. I think it's your webpage, no? Jayakumar.
Yes.
Yeah. I think you can visit that webpage to know much more about that, so that you can have connection with the SAR for future. We are all working in college, sir. If you possible, if you are in Chennai or Bangalore, sir?
Bangalore, sir, but of course, body is in Chennai. But Bangalore, mind is in Chennai.
Okay, sir. Okay, sir. Anytime if you come to Chennai, please, sir. Please tell us. We will interact with you in person.
No, my recommendation for youngsters like all, sir, create your own web pages or group pages. Put all, because as human beings forget thing. No, if you accumulate this one thing, it will be good for younger generation to refer and then read. Some of them.
Yeah, like diary will keep us, but this will publish to all. That is one good things. Thank you all for joining this wonderful session. Thank you, sir. Thank you, ma'am.
Thank you. Thank you all. Good weekend.
Excuse me, sir. Small feedback.
Yes,
Yeah,
sir.
tell me.
Sir, absolutely. I used to work with the paper and the computer, and see, I will be establish something as a notes. And this session helped me to let back every and with the help of a website, and you can do those things. It's very interesting. Thank you, sir. Thank you so much.
Welcome. Thanks, my dear. If it's useful, please follow it up. It's good.
Definitely, sir. Definitely. Thank you, sir.
Thank you. Bye.
Thank you, ma'am.
Dr. Sharat, you are wanting to say something?
Yes.
No, sir. I just wanted to thank for always giving us a great opportunity by Mohan sir and a wonderful talk by Dr. Jayakumar ji. It's very interesting and
Mohan sir, thank you. Yes, I was telling Bani and please, below.
Jayakumar. Dr. Sharat is an expert in IoT security.
Oh, yeah, that problem is a very tough problem.
He had given an excellent presentation to us.
Yeah.
Now, I think we are working on conducting a full day program.
Oh, nice, sir. All the best. Tough problem.
continually keep in touch. So maybe we'll also find an opportunity to invite you physically because our party is here. So we'll find opportunities.
Come on, Bangalore also not too far. We have a good things here. Weather also good.
Yes,
Now,
sir.
of course, we have Mistral as a good company, leading embedded company in India. Of course, we have we are the prime and embedded things. We say we stand in that now. You can visit our lab also. It's a good thing. You can see a lot more things like modern Texas Instrument, Qualcomm's, and NVIDIA. All their process are getting sampled here, breathing
Yes.
works and things.
Thank you.
Sir, right now you are in IIEC Bangalore, sir? Or IIET?
Mistral Solutions. It's a Mistral Solution. It's near to Bangalore, near to a place. Nice
Okay.
company. Topmost company
Sure.
in embedded one. It's very good.
Thank you, sir.
Welcome. Thank you all. Thank you.
Thank you.
Thank you, Dr.
Bye.
Jayakumar.
Sir, Mohan sir, Romba, thank you. Thank you so much. Komathy ma'am, please take care. I felt, the starting line.
Thank you so much, sir, for your wishes.
Yeah, please, ma'am. It reminds us to do something and, how to even safely, and live inside the room also, I think.
Yeah. Thank you.
Bye.
Thank you, sir. Thank you for the session, sir.
Okay. Okay. Good night. Good night.
Good night, sir. Ma Divya, have you stopped the YouTube live streaming, ma? Okay. Thank you.
இப்ப எப்படி இருக்கீங்க கோமதி மேடம், எப்படி இருக்கீங்க இப்போ?
சார் வீடியோ பாத்தீங்கன்னா தெரியும்.
ஓ சரி, மொபிலிட்டி.
இது வந்து 1/3 தான். நான் ஐஸ் எல்லாம் உள்ள போயிருக்கு.
So you had some stitches and all.
Yeah, இன்னொரு ஸ்டிச் ரிமூவ் பண்ணல சார். இன்னொரு 5 days இருக்கணும்.
Oh, okay.
Okay, so it's a tremendous impact.
I think that even
Yeah, it's all swollen and